so let's have this example. Alright, also a previous board exam for civil engineering, a previous board exam problem. So we have a ladder weighing 600 newtons is prevented from sliding down by exerting a horizontal force at C. The coefficient of friction at A, so we have this. Okay, at A, we have the coefficient of static friction to be 0.2. While at B is a smooth plane. Therefore, there will be no frictional force at point B. What is the horizontal force exerted at point C? So before we proceed with our solution, let us first establish the forces. So we have the first one. This is the weight of the ladder. This is 600 newtons. It is assumed to be acting at the mid-length. If we have a weight or the self-weight, it should be acting on the mid-length of the ladder or its centroid. So this is at a distance 3 meters from point B or 3 meters from point A. Okay, so other than that, what are the reactions? So we have the vertical reaction at A. Since this is the perpendicular reaction, we assume this to be a normal reaction at A. Since we have a frictional coefficient of friction at point A, we are considering frictional force at point A. Since we are preventing the ladder to slide down, what will be the direction of the frictional force at A? It should be to the right. And this is, let's say, the frictional force at point A. Since we don't have a frictional force at B, since it is a smooth plane, we will be having a normal reaction at point B. Let's say this is and so B. So those are the support reactions. So how to compute for the normal at A? We can have it by summation of forces vertical equal to 0, upward forces to be positive. So what are the vertical forces? The weight of the ladder, the normal reaction at A. So basically, the normal reaction at A is simply equal to the 600 newtons. Okay, how to compute for the frictional force? Frictional force at A is equal to the coefficient of static friction multiplied by the normal reaction. So mu, normal force for the frictional force. So we have the frictional force at A is equal to, we have 0.2. Okay, so what is the normal reaction at A? That is the same as 600 newtons. So 0.2 of 600 newtons. The frictional force at A is equal to 120 newtons. Okay, so since we have this value, the normal reaction at A, the frictional force at A, we can do summation moment at B to compute for this force F. So let's say, summation of moment at point B equal to 0, clockwise moments to be positive. So that's the moment. We have this is 600 newtons. What is the lever arm? This distance. That is the same as, this is 6 meters. 6 meters cosine of 30 degrees. This horizontal distance. Then we have, this is minus 120 newtons. What is this distance? Vertical distance. That is 6 meters. Opposite, we have 6 meters sine of 30 degrees. Then this is also a negative. The self-weight, minus 600 newtons. It is assumed to be acting at the centroid of the ladder at a distance of 3 meters. That is 3. Okay, this distance is 3, the same angle, 3 cosine of 30 degrees. And finally, we have the first F. The first F, lever arm, this is 4.5 meters. That is the same as 4.5 sine of 30 degrees equal to 0. So the line of action, this distance is this is the same as 30 degrees. So this is the same as 4.5 sine of 30 degrees equal to 0. So let us now compute for that force. So we have 600 times 6 cosine of 30 degrees minus 120, 6 sine of 30 degrees, and minus 600. This is 3 cosine of 30 degrees. I divide by 4.5, then divide by sine of 30 degrees. So we have an answer of 532.82 newtons. That will be the horizontal force exerted at point C. Let us check on our choices. 532.82. The nearest value is letter D, 533 newtons. So let's have this problem. So a homogeneous ladder, 20 feet long, weighing 50 pounds. So again, if the weight of given object is given, we assume it to be acting on its centroid. So let's say this is the 50 pounds weight of the ladder. So since the length of the ladder is 20 feet, let us assume that it is acting at a distance of 10 feet from each end. Okay, so leaning against a wall makes an angle of 15 degrees with the wall. So if this is 15 degrees, we assume the angle will be 90 minus 15 with the floor is 75 degrees. So assuming that the coefficient of friction at all contact surfaces is 0.20. How far up the ladder will a climbing man weigh 150 pounds before slipping of the ladder impends? So if we have the term impends, which means the ladder is about to move or start to move, the analysis is still statics. We are not to consider the problem to be in dynamics, since the motion is just about to start. Okay, so we are to place that 150 pound man, let's say at a distance x from A. So we have a weight of 150 pounds. So we assume that its position from A is at a distance of x. So we are looking for this distance that the man will climb before the slipping of the ladder impends. So we have now the loadings, the self weight of the ladder, the weight of the man. Let us establish the support reaction. So we have the normal reaction at A. So let's say this is N sub A. So since the ladder is about to slip, what is the direction of the frictional force at A? It should be inward or to the right. This is the frictional force at A. Then we have, this time we have a frictional force at point B. Other than the normal reaction at B, this time we'll be having a frictional force. And its direction, so if the ladder is about to slide down, the frictional force should be upward. This is the frictional force at B. So how do we compute for this value of x? I think we need first to determine the value of the frictional force and normal force at B. Let us use the three equations of equilibrium. So after establishing our force direction and support reactions, this is by summation of forces vertical equal to 0, upward forces to be positive. We have the normal reaction at A plus, this is the frictional force at B is equal to the weight of the ladder, this is 50 plus the weight of the man, 150. So this is the same as normal reaction at A plus the coefficient of static friction, normal reaction at B equal to 200 pounds. Or this is the same as the normal at A plus, what is our mu? 0.20 of the normal reaction at B is equal to 200 pounds. So let this be our equation number 1. Okay, so let's have the summation of forces horizontal equal to 0. To the right forces to be positive. What is the to the right force? We have this one. That is the frictional force at A. Okay, and the other, we have only two horizontal forces. The frictional force at A, the normal reaction at B. So basically equal to the normal reaction at B. So what is the equivalent of a frictional force? That is the coefficient of static friction. Normal reaction at A is equal to the normal reaction at B. What is our mu? We have 0.20 normal at A equal to normal at B. Okay, so since we have that equation, we may solve one of the unknowns. Okay, by substitution. So let us compute for the normal reaction at A. So we have normal reaction at A from equation 1 plus 0.20 of normal at B. What is the equivalent of normal reaction at B? That is the same as 0.20 normal reaction at A, and this is equal to 200 pounds. So therefore, first thing to solve is the normal reaction at A. So this 1 plus 0.2 squared. We have 200 divided by that value. Is equal to 192.308 pounds. So normal reaction at A is equal to 192.308 pounds. So we can now compute for the normal at B. What is the equivalent of normal at B? The normal reaction at B is equal to 20%, 0.20 of normal at A. 192.308. So we have the normal reaction at B is equal to, that is 192.308. And we have 38.462 pounds. And we can have also the frictional force at B. This is the frictional force at B is equal to, we have 0. Mu, that is 0.20 of normal at B. So 0.20 of 38.462 pounds. We have now the frictional force at point B is 0.2 of 38.462. So we have this value as 7.692 pounds. Okay, so last thing to do will be doing summation moment. And the summation moment about point A to compute for the value of x. So this is the summation of moment at A equal to 0, clockwise moments to be positive. So let's have the weight of the man. And the weight of the man is 150 pounds. What is the lever arm, or how far is it what is the perpendicular distance about point A? That's the same as distance x, cosine of 75. So this is x cosine of 75 degrees plus the weight of the ladder. This is 50 pounds. Again, it is acting at the mid-length of the ladder. So that's the same as 10 cosine of 75 degrees. Okay, then we proceed to the counterclockwise. Minus normal at B. Normal at B is equal to 38.462. Lever arm, what is this height? That is the same as 20. It's 20 feet long ladder. 20 sine of 75 degrees. Minus, so minus the frictional force of B, that is at a distance of, the frictional force of B is 7.692. The lever arm, 7.692. Lever arm is 20 cosine of 75 degrees equal to 0. So let us compute for ay the value of x. So this is the same as 50 times 10 cosine 75. Okay, minus 38.462 20 sine 75. Then minus 7.692 20 cosine 75. Ito divided by 150, then divided by cosine of 75 degrees. So we have that value as, we have 16.831 feet. Alright, so let us check on our choices. 16.831 feet. Okay, the nearest value is letter A, 16.8 feet. So let us discuss a little about a vector. So for example, we have a vector. So let's say this is a vector A with the elements. Let's say this is A1 for unit vector. This is A1I plus the A sub 2j plus the A sub 3k. So some of the questions for vectors, how to determine the absolute value of vector A. So the absolute value of vector A is simply equal to, this is the same as A1 squared plus the A sub 2 squared plus A sub 3 A sub 3 squared. That is the same as the absolute value of a three-dimensional vector. So for example, what are the operations for vectors? So we can do addition or subtraction. So for example, we have vector A with the elements 5i plus 2j minus 3k. So we have vector B, let's say this is 4i minus 7j plus 2k. So for example, the required is, what is the absolute value of vector A plus vector B? So we have to do is, let us first determine the value of vector A plus the vector B. So we have to do is, combine, or you are to do addition of the same components. That is, we have a plus, we have that is 5 plus 4, this is I. Then we have plus, that is 2 minus 7 of j. Then plus, this is negative 3 plus 2 of k. So we having the equivalent of vector A plus vector B. This is now 9i plus, or that is minus, this is minus 5j. Then negative 3 plus 2 is negative k. So this will be vector A plus vector B. So if you are looking for the absolute value of vector A and vector B, that is the same as the square root of 9 squared plus, we have negative 5 squared, plus the negative 1 squared. So let's have this value. So we have the square root of 9 squared plus 5 squared plus I1. That is the same as the absolute value of vector A plus the absolute value of vector B is equal to the square root of 107. And other than addition of vectors, we have the other operation for vector or vectors. So first we have the dot product. So if you have to perform dot product, the resulting product will be a scalar quantity. So that's why it is also known as the scalar product. That's the same as A dot B equal to we have the absolute value of vector A multiplied by the absolute value of vector B cosine of theta. So when it comes to that product, A dot B is the same as the B dot A. Okay, so that is for that product. If you have a simple equation for that product, okay, A dot B is the same as A1 B1 plus the A2 B sub 2 plus the A sub 3 B sub 3. But you can do this on your calculator using mode vector. Then we have, other than the dot product, we have the cross product. So the resulting product is obviously a vector. Okay, cross product of two vectors is always a vector. So that is the absolute value of A cross B is equal to the absolute value of vector A, the absolute value of vector B. This time we're using the function of sine theta. Okay, take note that A cross B is not equal to B cross A. Okay, so we have A cross B is basically equal to negative B cross A. Okay, so to other operations when it comes to the dot product and cross product. By the way, cross product is more convenient if you're using the mode vector of your calculator. So let's have an example. Let's have this example. Given the vectors, compute the triple scalar product, that is A cross B dot C. So we have A with the elements 8i, 4j minus 2k, B, this is 2j, 6k, and we have C, this is 3i minus 2j plus 4k. So since we have this calculator with a mode vector which is allowed by PRC, it is more convenient to use our mode vector. So let us use mode vector. It's the same as mode number 8. So mode number 8, then we choose number 1. This corresponds to a vector at A. So number 1. Then since we have 3 elements or 3-dimensional vector, this is, we choose 1 is to 3. And then let us input the elements of a vector A. So the elements of vector A, we have, this is 8, positive 4, then negative 2. So we have 8, 4, negative 2. After that, after entering the data for vector A, you are to press shift ups. Then choose number 2 to input another set of data. So this number 2, then we choose this time number 2. This is for a vector B. Then again 1 is to 3, since we have 3-dimensional vectors. But as you can see, we don't have the first element of vector B. So this is 1. So we put the first element to be. The first element will be 0, a positive 2, then a positive 6. So we have 0, 2, and 6. Then just repeat the process to input the data. We have shift ups. And then number 2 for the data. Then this time, number 3 that corresponds to vector C. Then again 1 is to 3 to input the elements of vector C. So the elements of vector C, this is positive 3, we have negative 2, and positive 4. So we have 3, negative 2, then positive 4. After that, you may press CA or clear all. So the same, almost the same procedure if you are using the previous calculators allowed by PRC, the 570 ES Plus or the 991 ES Plus. So we are looking for the equivalent of the A cross B dot C. So we are to shift ay shift ups. So, before that, we may first input an open parenthesis, then shift ups. And then we choose number 3. This corresponds to vector A. So we have number 3. Then ordinary multiplication sign for the cross product. And then repeat shift ups. This time we have number 4, that is vector B. Then close parenthesis. Alright, then we have again, repeat the process, shift ups. So look for that. That is at number 8. We press number 8. Alright then. I repeat the process. We have shift ups. Then this time we have number 5. This corresponds to vector C. So that's number 5. So what is on our screen should be, the screen of the calculator. This is vector A cross vector B, dot, the vector C. Then we press equals, and that is equal to, we have 244. That will be our answer. Let us check on our choices. We have letter B, that is equal to 244 pounds feet squared. So we have to place the unit. 244 pounds feet squared, or foot squared. This is our mode vector in our calculator. If you are to perform cross product and dot product. Let's have this one. This is a past board exam problem for vector. So find the angle between two vectors. Let's say we have vector A with the elements 4i plus 12j plus 6k. Vector B with the elements 24i minus 8j plus 6k. So the most convenient procedure to use for the computation of the angle between two vectors is the dot product. We have the A dot B is equal to the absolute value of vector A multiplied by the absolute value of vector B cosine of theta. So what is the value of the absolute value of vector A? That is the square root of its elements. We have 4 squared plus 12 squared plus 6 squared. So what is that absolute value equal to? The absolute value is equal to, this is 14. What about the absolute value of vector B? We have the absolute value of vector B is the square root of elements. We have 24 squared plus negative 8 squared plus positive 6 squared. We have the absolute value of vector B. That is equal to 26. Okay, so if you are looking for the dot product, this is A dot B. We have A1 B1 plus A sub 2 B sub 2 plus the A sub 3 B sub 3. Sometimes it is more convenient to do it manually if you are doing dot product. Dot product recommended do it manually, but for the cross product you may use the calculator. So we have, this is now A dot B. What is A1? We have 4. B1 is 24 plus A sub 2 is 12, B sub 2 is negative 8 plus A sub 3 is 6, B sub 3 is also 6. You have the value of A dot B is now equal to, We have that is 4 times 24 plus 12 times negative 8 plus 36. Okay, this is equal to 36. Okay, so we now compute for the angle. So we have A dot B is equal to 36 equal to, what is the absolute value of vector A? We have, this is 14. The absolute value of vector B is positive 26. This is cosine of theta. So let's have the angle between the two vectors. This is the same as 36 divided by 14 divided by 26. Shift cosine of the answer is equal to 84.324 degrees. So 84.324 degrees, and our choices, we have letter C. So let's have this example. So maybe this is one of the most famous tripod problem in civil engineering board exam. So a tripod supports a load W as shown in the figure. If the weight is equal to 50 kilonewtons, which of the following most nearly gives the force in member AB? So we have the points, this is A, AB, and this is C and point D. If we are to analyze the forces, this is the actual force for member AD. So we have the force for member AD, the force for member AB, and the actual force for member AC. But if you are to observe, when it comes to dimension, basically the actual force, supposedly, the actual force for member AB, the actual force for member AB should be equal to the actual force for member AC. So let us use the slopes. The slopes are the dimension for the summation of for the equation of equilibrium needed later. So let us determine the lengths. So the length of member, so we have AC is the same as AB. So this is for AC and AB, which these two members are identical. The equivalent length of AC or the length of member AB is equal to the square root of, if you are to observe the dimension, that is 1.8, three-dimensional. So 1.8 squared plus, that is only 0.9. So this is, we are considering 1.8 plus, we have 0.9 squared plus, what is the height? We have, this is a 2.4. So let us determine the length of member AC equal to the length of member AB. Equal to, we have the square root of 1.8 squared plus 0.9 squared plus the height, 2.4 squared. So that will be equal to 3.132 meters. And the unique member, that is AD, for member AD, this is the length of member AD is equal to the square root of, it is only a 2D, it is 1.8. We have 1.8 squared plus the height, this is 2.4 squared. So we have the length of member AD is equal to 1.8 squared plus 2.4 squared. So that is 9. We have the square root of 9s. It is 3 meters. So usually if we have a 3-dimensional problem, we can convert this one into a 2D problem. So since it is we are to convert it to a 2-dimensional problem, we are just to consider the x-axis and the y-axis. So let's say this is at a distance of 0.9. At this point, if we are just considering y-axis and x-axis, let's say at this point, the visible point is point B, or behind we have point C. That is at a distance of 0.9 meter from this origin. So let's say this is our origin. And then we have at point D, it is at a distance of, it is at a distance of 1.8 meters. At this point, we have the weight equal to 50 kilonewtons. So if we are to consider the vertical component of the axial force for member AB and AC, so we are to just to consider one arrow. Let's say this is the vertical component. Supposedly this is the force. What is the vertical component of the axial force for member AB? The vertical component of member AB, that is 2.4 divided by its length. We are using its slope. That is, we have the height of 2.4. This is divided by the length. We have 3.132 meters. So it is AB or AC. Take note, the axial force for member AB is equal to the axial force for member AC since they are identical. So it is AB or AC. Now if we are to do or consider the axial force or the vertical component of the axial force for member AD, that is the axial force for member AD. We have the vertical component. What is the vertical component? That is, we have 2.4 meters. And this is 2.4 divided by the length of AD divided by 3. Now, we are looking for the axial force for member AD. We may do summation moment about D. So this is summation moment at D equal to 0. Clockwise moments to be positive. So what are the clockwise moments? We have member AB. That is member AB. So we are using member AB. Vertical component is 2.4 divided by the length 3.132. Okay, we are multiplying it by 2. So why do we need to multiply it by 2? Take note, we have two forces there. That is the vertical component for AC, this is AC. Vertical component is 2.4 divided by 3.132 meters. And the vertical component of AB, which is this one. But since they are equal, we are just using AB since it is the unknown. So we multiply it by 2. How far is this point B from point D? 1.8 plus 0.9 is equal to 2.7. Minus the weight, 50 newtons. How far from point D? It is 1.8 meters equal to 0. So let's have the axial force for member AB are the same as the axial force for member AC. This is the same as 50 multiplied by 1.8 divided by 2.7 divided by 2 divided by 2.4 over. So we have that value as the 21.75 kilonewtons. That will be the axial force for member AB and also equal for the axial force for member AC. Let us check on our choices if we have that value. We have letter A, this is 21.75. So we are just converting three-dimensional problems to 2D for an easier analysis.